Welcome to S&D College of Engineering and Research Center, Yola, Department of Applied Science online lecture series for first year engineering. I am Assistant Professor of IRMAM from first year engineering department, course Engineering Physics. Today we will discuss about lasers. You have already learned or listened this word lasers. So our unit number 2, laser and optic fibers. So history of lasers. History of laser is the laser is invented in 1958 by Charles Townes. This Charles Townes, Nobel Prize in Physics 1964, and Arthur Scalo of Bell Laboratories. We, based on Einstein's idea of particle wave duality of light more than 30 years earlier, originality called maser. Maser means M is microwave and lasers. You can listen this laser word in day-to-day life, just like laser printer, laser pointer, laser batteries, laser operations. So, what is laser? What is the long form of a laser? Light amplification by stimulated emission of radiation. This is the long form of light amplification by stimulated emission of radiation. A device produces a coherent beam of optical radiation by stimulating electronic, ionic or molecular transitions to higher energy levels. The laser works only stimulated emission process. In this there are three processes: stimulated absorption, spontaneous emission and stimulated emission. The laser only works in stimulated emission. The molecules transition higher energy level to lower energy level. When they return to lower energy levels by stimulated emission, they emit energy. In this video lectures, we can see properties of lasers. There are four properties: monochromatic, direction, coherent and intensity. So one by one we will discuss. The light emitted from a laser is monochromatic. That is, it is of one color wavelength. In contrast, ordinary white light is a combination of many colors of light. Monochromatic means what? The laser light only in one color. Monochromatic means mono means one, chromatic means color. The laser light is only travel in one color. This is the property of laser. Monochromatic means one color. Second, directional. Laser emit light that is highly directional. That is, laser light is emitted as a relatively narrow beam in a specific direction. The laser lights emit only in one direction and narrow beam. They travels only one direction, that's why they are traveling in narrow beam. Then ordinary light. If you have to see ordinary light, there are more directions. They do not travel in only one direction. Such as from a light bulb is emitted in many directions away from the source. If we distance is increases to source, then the ordinary light spread. But if we increase the distance with laser light, they do not spread. Their direction is only one. Next property, the light from a laser is said to be coherent. Coherent means the wave have same phase and same wavelength. The light from a laser is said to be coherent, which means that the wavelengths of the light are in phase in space and time. Ordinary light can be a mixture of a many wavelengths. These three properties of a laser light are what can make it more hazardous than ordinary light. Laser light can deposit a lot of energy within a small area. First, monochromaticity. Monochromaticity means the distance between crystal of one color, nearly monochromatic line. Comparison of the wavelength of a red and blue light. This is the property. Monochromatic means single color. Examples: helium neon lasers. Next property, directionality. On the screen you can see normal ordinary light and laser light. Normal ordinary light, the light rays are spread into all directions, but you can see on the figure laser light only in one direction. They do not travel in all direction, only in one direction. The first is a convection light source and diversion angle is theta d. In beam divergence, theta d is equal to beta lambda upon d. Then beta is nearly equal to 1. Lambda is the wavelength and d is the beam diameter. And next property, coherence. Coherence, on the screen you can see in first box incoherent light waves. There are number of waves are traveling different phase and different wavelength. These light rays are ordinary light. In second line box you can see in this box also number of lines, but these all waves are traveling same phase and same wavelength. They there have crest and crest same and trough to trough same. This is the coherent light waves or laser light. On the screen you can see incandescent light or laser light. The incandescent light have many wavelength, multi-direction and incoherent. In laser light, monochromatic, direction and coherent. Ordinary light have spread into different colors, that's why there are many wavelength. In laser they are only in one color, therefore they are monochromatic. The ordinary light or incandescent light are spread into all directions, but laser light are spread into only one direction. That's why incandescent lights are multi directions and laser lights are direction. Incandescent lights are incoherent. Incoherent means their lights are intensity is less or more up to the distance, but laser light the intensity of light are same as to starting point to same as to ending point. That's why they are incoherent. Incandescent lights are incoherent and laser lights are coherent. The basic terms in lasers are absorption, spontaneous emission, stimulated emission and population inversion. This basic concept of lasers we will see in next video. Thank you.